Okay, so today we are looking at divisible and non-divisible sums difference. And so the question says we are given some positive integers such as the n and the m. And so we are defining integers as follows. So two integers, num1 and num2. Num1 is the sum of all integers within this range. So both are within this range from 1 to n, they are both inclusive. But num1 are the integers that are not divisible by m that will be given, and num2 are the integers, some of the integers that are divisible by m, and we are to return the num1 minus num2, that the sum of all integers that are not divisible by m minus the sum of all integers that are divisible by m, which is the num2. And to there's an example. Um, um, so num1 n is 10, and m is equal to 3, and so we have an output of 19. And so we can work through this example, and at the end of the day, 19 is our answer. Okay, so how they got it is that so integers in the range 1 to n that are not divisible by m are which the m being 3 here. So these are from 1 to 10. We can see this because you can see 3, 6, and 9 are left out, and these are the numbers. And so these numbers are the ones divisible by m, which is 3. And so when you sum these numbers up, they are 18, and when you sum these numbers up, the 1 to 37. So 37, which is num1, minus 18, which is num2, is equal to 19. Then we have our answer. So that's it. All right. Okay. So let's go ahead and see how we'll be able to solve this particular question. I'll copy this and then we come here. All right. Divisible and non-divisible sums. And so we have to return num1 and num2. Let me also copy this one here. And so num1, num2, and num1 is those that are not divisible by m. So num1 divisible by m, and num2 they are this confuses me. All right, this is not divisible by m, yes, and num2 is divisible by m. Let me put there the sum. Okay, I'll put here the sum. All right, so how are we going about this? We know that we are working within a range from 1 to n. All right, so 1 to n, and they are both inclusive. We can look at that from here, 1 to n, and we'll be giving n. So basically, our two inputs is going to be n. Let me just do this, and m. All right, so what I'm thinking is actually going through from 1 to n and finding all the numbers that are divisible by that particular m. Okay, so let me just see. So iterate through, iterate through from 1 to n inclusive. All right, and so um, find those divisible. All right, so we find those divisible by m. And so how do we find numbers that are divisible by m? So let's say if you are iterating through with a variable I, if I want to see that I is divisible by m, what I can do is I can say I modulo m. All right, if my I, sorry, it's not 1, I modulo m. So if my I modulo m is equal to 0, then that particular I is divisible by m. And so if it's divisible by m, that is we sum all those up as num2, and so we add I to num2. If not, so those ones that are so not divisible. So if they are not divisible, then we add the I to num1. Okay, and so we have to first have our num1 and our num2 both set to 0. Okay, and after that, once we've gone through 1 to n, we can actually return. So you can actually return the num1 minus num2. That's what you're supposed to return. This. All right. So let's go ahead and code this up. This will be the first approach. All right. The reason is finding the sum of numbers from 1 to n. There's actually a mathematical formula for it, and so we are going to look at that. So that would be like something like, let me see, approach 2. Okay, so let's first code approach one, and let's see. Okay, so I'm going back here and I'm going to copy all this. All right, so we're supposed to return the num1 minus num2, and so first of all we set our num1 and num2 is equal to 0, and we actually true with I. So let's do that. So num1, sorry, num1 is equal to 0, and num2 is equal to 0, and we actually true. All right, and I is equal to 0, I is less or equal to n and I plus plus. So we increment that, and so once we iteration through, we find out that are divisible by m. Okay, so if that particular I modulo m is equal to 0, then we add it to num2, which is keeping track of those divisible by m. So you see nums2 plus equal to I. Okay, then else, so we know that if it's not, if I modulo m is not equal to 0, that means it's not divisible by that. In that case, we increment the num1 by the I, and then once you are done, we return the num1 minus num2. Okay, so I can go ahead and test this particular one locally. Okay, so let me do that. So this is my test, and I'm testing the different sum with 10 and 3 now. The expected result is 19, and 5 and 6, the expected result is 15, as we have in this particular scenario. So 10 and 3, we are supposed to get 19, and 5 and 6 are supposed to get 15. So let me go ahead and, alright, so I compile that, and I run that. And so one test was successful. So our test was successful, and I'll go ahead and copy this particular solution and paste that here, and I'm going to submit them. Alright, so we see that 733 test cases passed. Okay, so our test cases passed. But what the approach I was talking about here, so let's try a different approach for this particular question. So with approach 2, so note that we are supposed to return this, right? We're supposed to return num1 minus num2. Alright, now what is num1 here? So the num1 here refers to the sum of all the integers that are not divisible by m. Okay, and num2 here also refers to the sum of all the integers that are divisible by m. So what I can do is that this particular num1 here, once I do have my total, so let's say I do have my total sum, and this total sum refers to the total sum of all the integers from 1 to n. Okay, and so once I do have my total sum, I can subtract it from my num2. Okay, so once this, the total sum of all the elements minus those that are divisible, those that are not divisible by, sorry, minus num2, which is the sum of the elements that are divisible by m, this results in this particular operation here. All right, and we can see that because total sum with sum of all the integers we have from 1 to n, then num2, which is the sum of those numbers that are not divisible by, that are divisible by m. Okay, sorry. And so once you subtract the total minus that, we are going to get the sum of those numbers that are divisible, that are not, so let's take note, that are not divisible. Let me just copy this, and let me just put here num1 so that I end up not getting confused. All right, so this would be my num1, so I'm supposed to return this. So let me do that. Let me just show you what I'm talking about. So I'm supposed to return this, and so my num1 here will be my total sum minus num2 minus num2. So all this represents num1. Okay, so I'm just going to copy this and paste this out here. When I simplify this, this is actually going to be 2 times num2. All right, it's actually going to be 2 times num2. Okay, as we have there. Okay, so this is actually going to be what I'm going to return. All right, but how can we get the total sum? how can we get the total sum? And so I can move here and ask, so let me ask ChatGPT to give me the math formula for finding the sum of integers, okay, from, we have from 1 to n. Let me inclusive, let me add this inclusive, sorry for the spelling of inclusive. Okay, so this is the mathematical formula, and so the sum of integers from 1 to n, where n is the last integer in the series, is given by this particular formula. So we can actually use this particular formula instead of using a for loop and all that. Okay, and that's why I said we have a second approach. Okay, so the last integer in the series, it's multiplying the last number in the series plus 1 divided by 2. Okay, so the total number is the last number in the series, which is n, multiplying the last number in the series, which is n plus 1, then divided by 2. This is basically the total sum. All right, and what is num2? Okay, what is num2 as well? So num2, let me just go back here. Num2 here is the sum of all the integers from 1 to n, both inclusive, that are divisible by m. Okay, and there's also a mathematical formula for that. So I'll go back here, and I'm going to say that give me the math formula for the sum of all integers in the range 1 to n that are divisible, all right, by a, say, by number c m. All right, let's use that. And good, so we are going to realize something here. Okay, they're talking too much. Okay, so this is actually what I'm looking for. You can read the steps, but there's some of the multiples of m, that is those numbers that are divisible by m, is given by the m times. This particular one looks familiar to this, if you notice. All right, if you notice this, in this particular scenario, our n was the last integer in the series, but in this particular scenario, our k is actually a factor, and that factor is given by k, but that factor is given by n over m. That's the last number in the series over what we are actually the divisible element. So we can say that the num2, which is the sum of all the integers that are divisible by m, is equal to the m times, then we have our k times our k plus 1, okay, divided by 2. All right, and that this particular k is given by n over m, and so I'll say that where k is equal to n over m. And so once we have that, we need not write a loop. Okay, so I can go to the Java. Let's code this up in Java, and I'm just going to remove this for loop here. All right, and so what I do have is my total sum here. Okay, so I'm going to have to return total sum minus this, so I just copy that and I replace all this. All right, so let's define our total sum. So our total sum is this particular one here, so I'll copy that and let me replace num1 with that. So the n times the bracket n plus 1 divided by 2. All right, then my num2 is also this, and so I'll replace all this one here with that, and this is num2 here. So let me just, that's an integer, this is an integer. Java doesn't joke with types. All right, and so our key now is equal to n over m, so I'll just say my int k is equal to n over m, and so with this I'll have my solution. Okay, so with the same test, let's actually test this. Let's see, so let me just clear, let me compile, then let me run. Okay, so one test was successful. Okay, so that's it. I'm going to copy this, same thing, I'm going to copy this, and I'm actually going to paste it in there. All right, and let's see. So I'm going to submit that particular solution, and we see that the test cases pass 737 out of 737. Okay, so with that we can submit the same solution for Python 3. All right, you can submit the same solution for Python 3, and using the same approach too, we are going to do that. So this is my main.py. Okay, so using the same approach, we're actually going to return this. So let me return this, and my total sum here, my total sum is this one here. So I'm just going to copy that. Okay, so the benefit of writing is that the benefit of doing this then is so that you see the approach and the steps, and once you start coding it becomes simple for you to just refer and pitch that. So this is my total sum. Once I do have my total sum, and my num2 is here, so I'm just going to copy my num2. Python doesn't end with this. So this one would be, we want integer division, we don't want floating point division, and so I'll use integer division here, and we have with our key. So our key is this particular one, and so I'm just going to put that here and use integer division here. Alright, so I'm not going to run this, I'm just going to copy and paste directly here and tab. Then let me submit this particular solution. Alright, and so we have the test cases passed. Alright, so this is the solution to the divisible and non-divisible sum difference. Alright, thank you.